Before we add a transistor to our circuit, we need to know something about it. There are some terms to know about transistors. A transistor is a device that is made up of semiconducting material, such as germanium or silicone, that can do several tasks depending on how it is set up and what kind of transistor it is. Those tasks are, it can be a switch, it can amplify, it can oscillate, and to a lesser degree, it can be used as a rectifier. There's different types of transistors. There's bipolar junction transistors, or BJTs. There's junction field effects transistor, or JFET. There are metal oxide semiconductor field effects transistors, or MOSFETs. There's unijunction transistors, or UJT, silicone-controlled rectifiers, SCR, and thyristors. Now here we see two setups, two construction techniques of transistors. And in our case, we're using a BJT, a bipolar junction transistor. It can be either a PNP or an NPN. And it depends on how the material, the order the material is set up in the transistor. And here's two illustrations. One is a PNP, and the other one is an NPN. Now, to make these semiconductors, which means sometimes they conduct, sometimes they don't, and to what degree they conduct, you can do something called doping. And doping is mixing a substance with the silicone, which could be either germanium. There's different types. Since we're not making transistors, we don't really, in this video, need to know what they are. We just put this doping material in there. You dope the silicone with a material that increases the number of available holes. Holes are electron acceptors. Holes allow electrons to flow through a conductor. This causes a decrease in the resistance of the silicone. How you put them in order determines what kind of transistor you have. A lead or a pin is a prong coming out from the bottom of the transistor that is connected to either an N or P-type material and is used to connect the transistor to the circuit. The base is usually between the collector and the emitter, and then the collector is on one side of the transistor and the emitter is on the other side of the transistor. The junction is the border between the N and P type of material. Then there is an orientation marker. An orientation marker is used to determine which lead or pin is which one is which is the collector, what's the base, what's the emitter. Okay, in this application, we're using a BJT as an amplifier. It comes with the three leads. The three leads are the emitter, the base, and the collector. And then our orientation marker as a reference to aid in determining that lead. It can be a tab, a flat edge, or a flat face, or a notch, or it can even be a dot. It can be almost anything. Your data sheet for your transistor will help you identify what is what. If you don't have the data sheet, you may be able to find one on the internet by looking up the part number of the transistor. The part number should be stamped on the transistor. Now, with our BJTs, you can have the two different constructed layouts, the PNP or the NPN. Here's the schematic symbol for a PNP. And this symbol is for the NPN. Now, an easy way to remember a PNP and an NPN for the symbol, the schematic symbol, is you notice the arrow pointing in on the emitter. That is the emitter. The arrow is pointing in on a PNP. And just take the two first letters of the PNP, PN, pointing in. On the other one, where the arrow is pointing out, it is not pointing in. Just take the three letters, the NPN, and you have not pointing in. And this layout determines how the transistor is wired in the circuit and what it does. For the PNP transistor, you usually connect the collector to the negative side of the battery or voltage source, and the emitter goes to the positive side. With the NPN, it's just the opposite. So again, our PNP transistor's internal arrangement is like this, and its schematic diagram is like this. Now, you will hear a term called bias or biasing. This is a voltage, usually small, about 0.6 to 0.7 volts, that sets up how the transistor will operate. It's actually just a voltage applied to the base to get the transistor to allow current to pass from the emitter to the collector. If you wire the transistor in and don't connect anything to the base, it will not, under normal circumstances, conduct electricity. You will find no voltage or current flowing through the transistor. Once you connect voltage to the base, it allows the transistor to start conducting through the emitter and the collector. The one way to look at it is like a gate. The gate is closed if there's no voltage on the base. You get the base voltage, the gate opens. Now, a thing to be careful with transistors, and I have burned up transistors before, at least one, is that there's a maximum amount of current and voltage that a transistor can handle before it overheats and burns up. And the hotter the transistor gets, the more it conducts. And the more it conducts, the more it heats up. So you have this cycle. This action can keep building up until the transistor burns up. It's called thermal runaway. To prevent thermal runaway, you install a limiting resistor at the collector of the transistor to put the brakes on the transistor, to slow it down, to limit that so it doesn't burn up. If you don't have that resistor, you will destroy the transistor. If you saw one of my earlier videos where I put the light emitting diode in this circuit that we're working on, we added a resistor for the purpose to limit the current through the diode so it wouldn't burn up. So that's the same idea with the transistor. In fact, speaking of diodes, a transistor is like two diodes connected together. So in this circuit, we've connected this PNP transistor emitter to the positive side of the battery. The collector is connected to the negative side of the battery. Now the collector is considered to be the output of the amplifier. So it could feed another amplifier, so you have two amplifiers. It could feed a chain of them. Or it could go into a mixer or into a speaker. So how is the signal actually amplified? You take the signal you want to be amplified, the smaller signal, and feed it through the base. When it goes into the transistor, it allows the transistor to start conducting between the emitter and the collector. The battery is 9 volts. That's a lot of volts. And it has a high current, a fairly higher current than what's at your base to go through the transistor. When the base voltage goes into the transistor, it allows conduction, and that current from the emitter to the base, the emitter to the collector, will mimic the base signal at a bigger voltage and current. That's where your amplification comes from. That 9-volt battery is bigger than what the base is. It mimics the base current at a bigger amplitude. So it will amplify the signal, but there's one thing, the signal, usually in these amplifiers, the signal will be 180 degrees out of phase, meaning instead of it rising first and then dropping down and then rising again, it'll go down first when it comes out of the transistor, and then up, and then down. It's usually not a big deal. For our circuit and for what we're doing, it doesn't matter. In some applications, you have to consider that reversal, but not in this one. Well, I hope you learned something from this video. I hope you enjoyed it. If you did, please give it a like and please subscribe.